screen. That'd be a lot of money that I just don't have. All right, let's go. All right, so we started talking about particle motion. So I told you guys that the velocity is the first derivative per position, all right? And that will give you the slope of position. That will tell you how the position is either increasing or decreasing, depending on the sign of the velocity. Displacement is just another fancy word for saying change in position. Distance traveled is the sum of the absolute values between resting points, all right? So that's like whenever the value of your slope changes, whether it be from positive to negative, negative to positive. Average change in position is called average velocity. Average velocity, you use kind of the Algebra 1 way of calculating slope. Instantaneous change in position is called instantaneous velocity, which is the velocity function. The derivative of velocity is acceleration. All right, so that's kind of a good thing to kind of remember. Correct. Right. So if they were asking you, what is the speed over a particular interval, even though your velocity might be negative, to calculate the speed, you would just take the absolute value of it. But most of the time what you guys will see with regarding to speed is you have to kind of connect both acceleration and velocity together. So the first one that I have here is if both the velocity is positive and the acceleration is positive, or if the velocity is negative and the acceleration is negative, then speed is increasing. So they both have to be working with each other, right? So if velocity is positive, acceleration is positive, that means they're working together. So the speed of your particle is going to be going up. If they're both negative, that means they're working together. That means still your speed is decreasing. So you have to kind of check the value at whatever x value they kind of give you. You have to check the signs for both your first derivative and your second derivative, and that will tell you whether the speed is increasing or decreasing. Now, if they're opposite signs, so if one is positive and the other one is negative, like in this bullet here, then your speed will be decreasing because they're working against each other. Okay? If your velocity is positive, then your position is increasing and motion is in the positive direction. So usually think of it kind of like an XY axis, right? So if you're going in the positive direction, if we're talking about a horizontal particle, we're talking about going right. Or if we're talking about a vertical particle, we're talking about going up. Right? So think of up and going right as being positive. Okay? And then if it's negative, velocity is negative, then your position is decreasing and your motion is going in the negative direction, which is either left or down, depending if you are moving horizontally or vertically. If your acceleration is positive, then your velocity is increasing. Right? So if the slopes of your, if your acceleration is positive, then the slope of your velocity is going up. And then the same thing, if it's negative, that means that velocity is going down. And then direction changes when velocity changes from either positive to negative or negative to positive. All right, so, right. Mm-hmm. So if you were to start with position, you would take the derivative and then the derivative again to get acceleration. Right, exactly, yes. Say again? S is position. Right, exactly. Exactly. Yep. Yeah, so always remember the order: position, velocity, acceleration. All right, so number 3, do you have a particle moving? Not memorize it, but like, not memorize, but you need to know how to apply it. Like, so. Right, exactly. Same thing. Okay, so you have a particle moving along a horizontal line. So that means all my particle is doing is moving left or right. All right, so that part's important. Its position at any time t is greater than or equal to 0. That's important. Is given by the function x of t is equal to that. X is measured in feet, and t is measured in seconds. Okay, so we're talking about, some particle moving left or right, and we want to figure out at what particular time is it moving left, is it moving right. Okay, so it says find the displacement of the particle during the first 3 seconds and then explain its meaning. So, displacement is just a fancy word for change in position. Right, so like when I did yesterday when I was like walking back and forth, even though I'm collecting distance, I might have only moved really 2 squares over instead of, even though I'd maybe walked 10 squares, I've only maybe moved over 2 squares. So that's what displacement is. All right, so in order to come up with displacement, you just need to figure out where it stopped and then subtract where it started. All right, so this is x of, so for the first 3 seconds, I stopped at when t equals 3, and then I started at 0. All right, so x of 3 is going to give me what? No. X is the function, not the variable. Zero, right? So if you plug in 3 into t squared minus 4t plus 3, you're going to get 0. And if you plug in 0, you get 3. So that comes out to be negative 3 feet. Right? So what this is saying, since it's negative, that means I moved in which direction? Left. Right. Which one? So you're plugging in 3 into this function here. Right? You're going to get an answer which is 0. Then you plug in 0, and you're going to get 3. And then you should just subtract the 2. You can literally just sew this setup, and you'll be fine. Yeah, where you stopped minus where you started. That's all. Where it stopped. And then x of 0 is where it started. No, but they'll tell you. All right, so the particle moves 3 feet left. Bring 0 less than t, which is less than 3 seconds. All right, so again, for this section, you have to get really good at interpreting what your answers are. So because my displacement was negative, that means I moved 3 feet positive 3, then I would be moving, right, exactly. All right, next one says find the average velocity of the particle during the first 3 seconds and then explain its meaning. So, average velocity is just another fancy way of saying the average rate of change of position. So this is kind of like your algebra 1 way of figuring out the slope of a line. All right, so you have average velocity is equal to now the change in position, which is actually what we just figured out. So you have x of 3 minus x of 0 all over the change in time, right? So during the first 3 seconds, we went from 0 to 3 seconds, okay? So now you need to make sure that you show this setup, all right? That will be like, if this is a free response question, that would be a point right there, just for showing that setup. None. There's six free response questions, and each of them are worth 9 points. Your final answer would be like your next point. No. So this would just be one part. Say there's like 3 parts to the question. This part might be 2 points. 2 of the 9. No. At least. Yeah. At least. No. All together, right? So say your free response question was A, B, C, and D. Right? Each of them, if I added the total points together for those 4 questions, that would come out to be 9. So like, so if I skip 2, I could get about like 8 points. Well, it depends on, because some are worth, again, more points than others, so. No. All right, what do we figure out x of 3 minus x of 0 was? Over 3, so we come out to be -1. Now, what's your units for velocity? Okay, good. All right, now we have to kind of connect this with so it says its average velocity is -1. So again, this is your change in position over the first 3 seconds, your average change in position. So you kind of need to put that into words. So during 0 is less than t, which is less than or equal to 3 seconds. Yes. The particle's position is, what is it doing? It's negative. Decreasing, right. Decreasing on average of 1 foot per second. Right. You have 2 calculator questions, which is 30 minutes. You have 4 non-calculator questions, which is 60. Not necessarily. Yeah. Again, we don't have enough calc knowledge right now to kind of do them, but once we do, I'll show you guys what they're looking for and all that stuff. Yeah, I guess that's all right. I think so. I mean, I just find it easier just to write it out, just to be sure. But. Okay, next one says find the particle's initial velocity and its velocity at 3 seconds. Okay, so it's asking you to find the velocity and its initial velocity. So initial means what? Like, yeah, but what would your time be if it's your initial? 0. And then you're trying to figure out it at 3 seconds, right? So you need the velocity function. So the velocity is the derivative of position, right? Which is what? So what's the derivative of x prime x of t? 2t minus 4, right? Right. Right. Yes. So the velocity is the first derivative of position, right? And they gave you the position function. So you take the derivative of that, right? Which was t squared minus 4t plus 3. So the derivative of that becomes 2t minus 4. So this is how this function here is going to give me the velocity at any moment. So I never took physics. So. Yeah, wasn't he? He's like in the Air Force and stuff. He like deals with planes and all that stuff. All right. So what's v of 0? -4 what? Okay. And then what is v of 3? Okay, good. All right, so since at 0, right, your velocity is negative, that means that your position is decreasing. And then at 3, your position is increasing because your velocity is positive. All right, so that's just kind of connecting the two together. All right, acceleration of the particle at t equals 4. So how is the velocity connected to the, or how is the acceleration connected to the velocity? First derivative. Right, which is, right, the derivative of the derivative. Right, so the second derivative of position is the first derivative of velocity, which is acceleration. So what, right, a of t would be 2, right? So what's the acceleration at t equals 4? 2 what? Feet per second squared. Because you keep dividing by like time. So like position doesn't have time with it. Velocity, you take like, again, the vertical divided by the horizontal, which is seconds, and then the acceleration, you do that again. You're dividing by time again. Correct, yep. Correct, yep. Yep. They won't ask you that. Yes. Yes. Okay, so so we can say at t equals 4 seconds. Right? You can have two different things. Right? You can say one, the acceleration is 2 feet per second squared. So acceleration is 2 feet per second squared. Or, since we figured out that the acceleration was 2, how does that connect with velocity? What is the velocity doing now? Particles velocity is what? So you have to look at the sign of what you got for acceleration. It's positive, so that means that the particle's velocity is right. Exactly. Yep. Now, if your velocity is 0, then it's at rest. So we figured out the acceleration was just 2. So no matter what value of t I plug in, it's always going to be 2. Okay. Right. Yeah, but you need to be able to recognize like both things. Like the acceleration is 2 feet per second squared is the same thing as saying particle's velocity is increasing. Right. Right. So at 3 seconds, is the speed increasing or decreasing? So it's asking for speed. So you need to kind of connect both velocity and acceleration. So what is the sign of, is it 3? Yes, 3. It's the acceleration part. So what would v of 3 be? Yes. What do you get? 2. 2 feet per second, which is greater than 0. And then what is a of 3? Right, which is also greater than 0. So, because they are both positive, they're working together. So that means that your speed is what? So speed is increasing. Yeah, this one is velocity, your first derivative. Acceleration is your second derivative. At t equals. Right. Yeah, you're only concerned with the sign at this point. Yes. That's a good question. So the absolute value of velocity will kind of connect more if you have like a graph of position. Then you want to kind of look at that. But if you have just an equation, then you want to look at velocity and acceleration. So, okay, so the next part says when is it moving left and when is it moving right. All right, so if it's asking you when is it moving to the left, you have to see when is your velocity exactly less than 0. So we figured out the velocity was 2t minus 4. So I want to see where is that less than 0. So I have 2t less than 4, so t is less than 2, right? So particle moves left for t is less than 2 seconds. Now, you can't really leave it like that because then where does it start? When do you start paying attention to the particle? 0. So you have to kind of include that for the first one. So the particle moves left for 0 to 2 seconds. And then when it asks you when is the particle moving to the right, that is when your velocity is positive. So you have 2t minus 4 is greater than 0, so t has to be greater than 2. So the particle moves right for t is greater than 2 seconds. It's changing direction, so right, because you're moving left, and then right at 2, you're now moving right, so it's changing direction. So that would be the next, actually, next answer. See how in the introduction it says so that's position at any time t is greater than or equal to 0. So that's when it starts. So you can't just let it go on forever in the negative direction. Say again? Make it dust. Make it a car. Make it an atom, molecule, whatever you want. All right, so when does the particle change direction? Right, so particle changes direction at t equals 2 seconds, since v of t, right, the velocity, changes from what to what? Okay. Negative to positive at t equals 2 seconds. I would put negative to positive because that's what you kind of showed earlier, like with the function being less than or greater than 0. All right, so anytime it asks you for when is it changing direction, you need to include this kind of statement here. So it changes the direction at this time since the velocity goes from negative to positive or positive to negative at this particular moment, right? So you have to kind of get used to writing, this sentence here. Yes. Yeah, that's, right. All right, last part says find the total distance during the first 3 seconds. So we figured out that the particle is at 3 at x equals 0. And it is at what when x is equal to 3? 0. And then at x equals 2, it's at -1. So the graph kind of looks like that. Okay? So when we said that it changes direction at t equals 2, right? So this is like a resting spot right here. So you want to figure out the distance from this point to this point. How much did it travel here? And then how much did it travel from 2 to 3 seconds? Okay, so what this is saying is that your position here is that it started at 3, right? And then it ended up at 0, right? So it moved 3 units to the left, right? So we want to see how much distance did I accumulate from t equals 0 to t equals 2, and then t equals 2 to t equals 3. That's part of the function. Like if you plug in 0 into the original, you'll get 3. Well, it's a quadratic, right? Because it's t squared. All right, now, distance is the absolute values between resting points. So I have the absolute value. It changes direction at 2, right? So x of 2 minus x of 0, right? That's like the first part here. And then the second part would be this piece here, right? So you're kind of putting those two together. So you have x of 2 minus x of 0 plus x of 3 minus x of 2. All right, so again, from t equals 0 to t equals 2, right? Your slope is negative, right? So you're moving in one direction. And then once you get to one direction, t equals 2, and then to 3, you're going in a different direction. So you're accumulating distance from here to here, and then here to here. So anytime you kind of like level off, that's where you want to kind of break it up. Yeah, yep. So x of 2 was -1 minus 3 plus 3 was 0 minus -1. Original, yep. So I get the absolute value of -4 plus the absolute value of 1, which is 5. So it traveled 5 feet in 3 seconds. Okay? Say again? Yeah, like I know it's probably not the best graph, but it's it's a quadratic. So like right here is like your vertex. The y-axis would be the position, like how many feet it is away from a particular spot, right? So like, my desk, like was the home. You got it? Okay. All right. Does anybody have their homework out? All right, so you guys can do like number 6 tonight, 7, 6, 7, 6, 7, and 10. Not yet. Probably tomorrow. 6, 7, and 10. Right. Any ones that have to do with like a table or a